Hello, all my AP Calculus students. Welcome to our little session here on picking up where we left off yesterday with these integrals with bounds on it. So first thing I want you to make sure you understand is that we're going to compute these integrals the exact same way we always have. The only difference is we've got some extra steps because these integrals have what we call bounds on them. And because they have bounds, this type of integral is referred to as a definite integral. So my goal today during this video is to give you the vocabulary and the notation that we rushed through at the end of class yesterday to make sure you guys are comfortable with. So I didn't call it this yesterday, but these are called definite integrals, and a definite integral is nothing more than an integral with bounds. That's all it is. So the way we compute it at the beginning, it doesn't change at all. It's just at the end when we have to evaluate it at the bounds, okay? We have been doing indefinite integrals this entire time up until yesterday. And I think you can figure this out. Indefinite integrals are integrals without bounds, okay, without bounds. So everything we have done up until last class is called an indefinite integral. And again, no bounds in an indefinite integral. So what I'd like to do is just go through this process. I know we did one yesterday at the end of class. We were really rushed. I want to make sure that you guys understand the notation and how to write it, because if you write it incorrectly, you're going to end up losing points. So let's not give the College Board any points that we deserve. So let's take it from the top. Let's go through this. Is it a one step? And in this case, I kept it simple. Yes, it's a one step. It's term by term. So the antiderivative is going to be x squared over 2 plus 4x. Okay. Now this is where the extra work starts coming in. Now you guys are going to say, well, wait a minute, don't forget your plus c. I'm going to have that plus c there. And that's true. And now we have to evaluate this. So some new notation. The first piece of notation that we have not used in the past is this thing called an evaluation bar. And the way the evaluation bar looks is like this. It is a vertical line. And it means that you evaluate at the bounds on the line. So we're going to say evaluate from x equals 2 to x equals 10. Now, the evaluation bar always comes after the expression. The biggest mistake I see students make, they want to put it here before the expression. The evaluation bar is always the last thing in that line, okay? So you've said, here's my expression, now I'm going to evaluate it. After the evaluation bar, you always get an equal sign every single time because that's the end of the line. So now you're saying we've got to evaluate our expression. So my advice to you is to set this up with two evaluations. You're going to evaluate this expression twice. And I like to use parentheses. You'll see why in a second. So what I'm going to do is I'm going to evaluate this expression. It's going to be something squared over 2 plus 4 times something. And now we're going to have that plus c at the end, okay? So because we're evaluating the same expression twice, all I got to do is duplicate this guy and put him in here, okay? Now, remember, the first evaluation is always for the top bound. The top bound always comes first, every single time, no exception. The top bound comes first. Obviously, the bottom bound will always come last. Okay, so what we want to do is we want to evaluate this thing. We're going to take it from 10 as our top bound. So we're going to substitute 10 into those two somethings. And now 2 is our bottom bound. So we're substituting 2 into these. Now, the last piece of this puzzle, when you're doing an evaluation bar, if there's only one number, you just evaluate that one expression with one input, you'd be all set. If there are two, if you've got an evaluation bar with a value on the bottom and the value on the top, the way you connect these two things is you always subtract them. And that is why it's so important that we have these sets of parentheses, okay? Because we're subtracting this whole first answer, and then we're taking away that entire second answer, and that's the idea. At this point in time, the calculus is over. This is just arithmetic. Can you go through and can you do the numerical number crunching here? So what's this going to be equal to? Well, this is going to be equal to, and it's going to go down to the next line. And we're just going to do this term by term. We're going to get 100 over 2 for this guy. 100 over 2 is going to be 50. 50 plus the next expression is going to be 4 times 10. That's going to be 40. And then we're going to have that plus c kind of just getting brought along. Now I'm going to do minus, and I'm going to keep those parentheses because I like to just focus on doing my numbers first. It's very easy to make a careless mistake if you forget to distribute. So I'm just going inside the parentheses, the way order of operations taught us. I'm going to do 2 squared over 2, which is 2. From there, I'm going to do 2 times 4 is 8. And then you're going to notice I'm going to have another plus c because I've got 1 in each evaluation. So that's where we are now. From here, we're going to go through and we're going to say that this is equal to our next expression. I'm going to combine these guys right here, and that 40 and that 50 make 90. I've still got that plus c. And now I'm going to be really careful about distributing this thing, okay? So I'm going to combine these first and get 10. So that's going to be minus 10. But now I've got to distribute that to the c. So that's actually going to turn out to be minus c. From here, what happens, that's really, really, really fortuitous for us, very nice. We get a plus c and a minus c, and those are going to cancel. So we're going to get this 90 minus 10 expression, and that's going to give us the answer 80. Okay, that's going to give us the answer 80. Couple of things you need to be aware of, okay? Every time we integrate, we have a plus c. But in this expression, because we're doing a double evaluation and we're subtracting, that plus c goes in the first one, it goes from the second one. We're always going to have a c minus a c. The c's are always going to cancel out. Because of that, in a definite integral, I'm going to stop writing the plus c because I'm looking into the future and knowing it's going to cancel out. It's still there, but why write it if we know it's going to cancel out? So for that definite integral, something to keep in mind from now on when we're doing a definite integral, no need to use plus c. For an indefinite integral, always use the plus c, okay? So a couple more things. The evaluation bar at the end, I'm going to keep saying that. A lot of you guys are going to screw that up. You're going to put it someplace else. The evaluation bar is always followed by an equal sign. Every single time in mathematics, that's how that notation works, okay? And then the last thing, or maybe the next thing I'll remind you of is 2 evaluations. So use your parentheses because it's the sign that's going to kill you on this, okay? Don't lose points because of 7th grade math. Don't lose points because of any math, but especially because of 7th grade math. So when you have the 2 evaluations, you're going to evaluate this twice. So 2 sets of somethings, and then it's always the top bound in the first one minus the bottom bound in the second one. At that point in time, it is just arithmetic, trying to come up with your final answer. So the last thing I want to talk to you about again is I just want to remind you something really important that we said yesterday. This guy here, the integral sign. It is no longer just the inverse of the derivative. It now has its own identity. What is the integral sign, everyone? That's right. It's the ultimate adding machine. I'm going to say it again. I'm going to ask you, what is the integral sign? You're going to tell me ultimate adding machine. Let's try it. What is the integral sign, everyone? I didn't hear you. Let me hear it again. Come on. What is the integral sign, everyone? It's the ultimate adding machine. That's right. Now.
The integral is the ultimate adding machine.
You heard it from the man. The integral is the ultimate adding machine. Everyone, have fun with this. We'll see you soon.